All right, sixth grade, continuing on in chapter 13, and today we are going to be talking about functions. So a function is a special kind of relation. We started talking about relations yesterday. With a relation, the same x-coordinate can be paired with more than one y-coordinate. We saw that a couple times yesterday. However, a function is a relation that does not allow this, okay? So a function is a relation that does not allow the same x-coordinate to be paired with more than one y-coordinate. So one more time, a function is a relation in which no two ordered pairs have the same first coordinate because the first coordinate is always the x coordinate, okay? So a function is a type of relation in which no two ordered pairs have the same first coordinate. So let's look at relation x. We have ordered pairs 3, 4, 0, 2, and 3, -5. When we make a circle mapping of those, we see 3 and we see 0, and then we see 2 arrows coming off of the 3, okay? 2 arrows coming off of the 3, which, as you will notice, we have a 3 in this one and a 3 in this one. Now, definition of a function is a relation in which no two ordered pairs have the same first coordinate. Well, in this one, we have 2 ordered pairs in relation x that have the same x coordinate. They both have 3 as their x coordinate. So, can relation x be a function? That's a big no. Okay, that's a big no. How about relation y? We have ordered pairs 4, 3, -2, 7, and 9, 0. Take a look at the circle mapping. We see a 4 to 3, -2 to 7, 9 to 0. Any of those x coordinates have 2 arrows coming off of them? No, none of the x coordinates are the same. So, is relation y a function? Yes, yes, it is. It is a function. How about relation z? We have ordered pairs 2, -1, 5, -1, and -3, 2. You'll see the circle mapping, 2 to -1, 5 to -1, and -3 to 2. Is relation z a function? Yes, it is. And some of you probably said, no, it's not. Why is it a function? It's a function because none of the x values are repeated. The definition of a function is that it's a relation in which no two ordered pairs have the same x coordinate. Okay, so even though this ordered pair and this ordered pair both have -1 as their y coordinate, it is a function because the y coordinates can be the same, the x coordinates cannot. So z absolutely is a function. Okay? Example number 1. Which relations are functions? So number 1 in example number 1, we have the set of ordered pairs 4, 9, 5, 8, 4, 3, 6, 9. Function or no? No. Why? Because 4, 9 and 4, 3, both of those have the same x coordinate of 4, so therefore this relation is not a function. Number 2, we have 3 points in a coordinate plane. Right here we have -2, -1. Up here we have 0, 2, and over here we have 3, 3. Is this a function? Yes, it is. Why is it a function? Because there are no 2 coordinate points that have the same x value. We have an x of -2, an x of 0, and an x of 3. So yes, this is a function. Number 3, we have a circle mapping, okay? We have 4 to 0, 7 to 5, -3 to 0, and 2 to 8. Is this a function? Yes, it is. It is a function because each of the x values is unique. Each of the x coordinates is unique. Now, we have 4, 0, and we also have -3, 0. So those are the same y coordinates, but that doesn't negate it being a function. It's only not a function if there are 2 or more x coordinates that are the same, not y coordinates. So the example of number 3 is a function. Number 4, we have some ordered or some points plotted on this coordinate plane. -2, -1, -2, -2, 1. Over here, we have 2, 3, and right here, we have 2, 5. Is the relation shown with these coordinate points in number 4 a function? No, it is not. Why? These 2 points negate it being able to be a function because we have the same x coordinate of 2 in both of those points. So this graph is not an example of a function. So again, in a function, an x coordinate is never paired with more than one y coordinate. Skill check number 1, is this relation a function? 2, 0, 3, -4, 5, 7, 6, 0, 7, -4, 10, 10. Do you see any x values more than once? I do not. So this absolutely is a function. Write a relation that is not a function. There's a million and one ways that you could write this. I'm just going to say 1, 3, put my brackets on, 1, 3, 2, 3, and 1, 17. Okay, this is not a function. Why is it not a function? Because I have an x coordinate of 1 in this point and an x coordinate of 1 in this point. This is not a function. Okay, a function can be formed by pairing the mountain altitudes with a code for rating the use of bottled oxygen. The rating codes are as followed. So if it's coded 1, that means oxygen is used as life support in the death zone, what's called the death zone, above 25,000 feet by most climbers. If it's coded 2, oxygen is used preventative above 20,000 feet by some climbers. And code 3, oxygen is used as medical treatment for climbers above 12,000 feet. The x coordinates of the function A, mountain altitude, rating code, are all numbers from 12,000 to 29,035 feet, which is the height of Mount Everest, the highest mountain in the world. The y coordinates are only 1, 2, or 3. Okay, so the x coordinates again are the altitude. The y coordinates are the codes, 1, 2, or 3. So example number 2 says, write an ordered pair using the function described above. Decide whether the mountain climber should use oxygen to climb the peak. So remember, we're using altitude, comma, code. All right, that's our ordered pair, x, comma, y, altitude, code. Mount Rainier is at 14,410 feet. So our coordinate point for A for this relation would be 14,410, comma, and then we need to see what its code would be. Well, it's 14,410 feet. So it's greater than 12,000 feet, but it's less than 20,000 feet, okay? So which one would that be, okay? Which one would that be? Which code? Well, that's going to be code 3 because you're going to use it above 12,000 feet, but we're not above 20,000 feet, okay? So that is code 3, okay? B, Annapurna, okay, is at 26,545 feet. So our x-coordinate is the altitude, 26,545. Our y-coordinate is the code, 1, 2, or 3. 26,545 is definitely greater than 12,000 feet, is definitely greater than 20,000 feet, and is greater than 25,000 feet, okay? So code 1 says used as life support in the death zone above 25,000 feet. So is 26,545 feet above 25,000 feet? Absolutely it is. So that is going to be code 1. Last C, we have Mount Logan at 19,551 feet. 19,551 is our X. Which code is it going to be? Well, greater than 12,000. But then code 2 is used greater than 20,000. Okay? So what code is C going to be? C is going to be 3, just like Mount Rainier was. Okay? Because 19,551 is between 12,000 and 20,000. Now, decide whether the mountain climber should use oxygen to climb the peak. Okay? So code 3 says oxygen is used as medical treatment above 12,000 feet. So is someone going to use oxygen? Not necessarily, unless they need it for some sort of medical emergency. So should they use oxygen to climb the peak? No, for A. B, should the climber use oxygen? Number 1 says oxygen is used as life support. Okay? If you are climbing a mountain, do you want to stay alive? Do you want your life supported? Hopefully your answer is yes. Okay? So should a climber, any climber, use oxygen if they are climbing in what's called the death zone? Yes, they should. And lastly, our last one, 19,551 feet, code 3, okay, used for medical treatment. Nope, no one is going to use oxygen. Just your average climber climbing it is not going to use oxygen or need oxygen, okay? Skill check number 2, Keith and Chevy paddle their kayaks at 2 miles an hour, and they know that their distance traveled is 2t, where t is the time that they paddle. How far can they paddle in each time? Okay, so 2t, where t is equal to time, and 2t, okay, is their distance. Whoops, distance. I can spell. Okay, 2t is their distance because they travel at 2 miles an hour. So their distance is equal to 2 miles per hour times however far or however long they are traveling for. So number 1, 3 hours. So t is 3. So how far did they travel? Distance is equal to 2t. So we're going to substitute 3 hours in for t. 2 times 3 is equal to 6. So in number 1, in 3 hours, if they are paddling at a rate of 2 miles an hour, they will cover 6 miles. Number 2, how far can they paddle in 5 hours? So they're paddling for 5 hours. Their t is 5. Distance is equal to 2 times t. So in this case, it's 2 times 5. 2 times 5 is 10 miles. So paddling for 5 hours at 2 miles an hour is going to get them to cover a distance of 10 miles. Now, number 3, come over here. Write the function that relates their time and distance for the following: half hour, 1 hour, 3 hours, 4.5 hours, and 5 hours. Now, function is a relation. So what they're really asking us to do is write the relation. All right, write the relation. X in this case, all right, X in this case is their time. Y is their distance. So XY is time and Y is distance. Okay, so for point 1 in our function here, we're going to have a time of 1/2 of an hour. And sorry, I'm not going to write hour. 1/2. Okay, how do I figure out how far they traveled? I do 2 times the time. So what is 2 times 1/2? 1. So in 1/2 of an hour, they travel 1 mile. There's my first coordinate point of this function. My second coordinate point is going to be how long do they travel in 1 hour. So 1 hour is my time. Plug in that 1 hour into 2 times t. So 2 times 1 is they travel 2 hours. Or 2 miles, excuse me, in 1 hour. Third coordinate point, all right? How far do they travel in 3 hours? So 3 is our x. plug in 3 for t. 2 times 3 is 6. They travel 6 miles in 3 hours. Then we have 4 hours. Okay, how far? Oh, excuse me, 4.5. 4.5 hours. How far do they travel in 4.5 hours? 2 over 1 times 4.5 as an improper fraction is 9 over 2. 2 times 2 cancels. That is 9. So in 4.5 hours, they cover 9 miles. And lastly, I'm going to try and squeeze this in with some room here. We're asked how far do they travel in 5 hours. We already figured that one out. 5 hours is 10 miles. Here is our function of time that they paddle and distance that they cover.